The second law of thermodynamics also says that the amount of useful energy in a system is slowly decreasing. This is also referring to what's known as heat death, that eventually all the universe will be transferred into nothing but thermal energy. And what that, if you really think about it, when we talk about all the laws of thermodynamics, it's all kind of leading up to that. We talk about methods of how energy is being delivered from one source to another. So let's start with the obvious one. Let's start with convection. So convection has two objects separated by a distance, right? And inside that space in between is a fluid. Okay, so energy is being delivered from this object into the fluid and then out of this object. So this object has so many joules of energy. Well, according to the zeroth law of thermodynamics, everything is trying to achieve a thermal equilibrium. The amount of energy that's leaving this system is not the amount of energy that's entering this system, because this object has to deliver energy, heat up this fluid, and then that fluid has to deliver energy into this system. This fluid has to store energy. It has to have the same thermal properties, not same thermal properties, the same temperature as this object and this object. They have to have that same equilibrium. It has to have that thermal equilibrium that's stated in the zeroth law. So that means the amount of useful energy that's coming from here is reduced by this object, this fluid, absorbing some of the energy and then delivering whatever it has left to this object. Okay? So there you see that we've lost some energy. It's gone into this fluid. That doesn't necessarily mean that that fluid doesn't have that energy. It's not that the energy is gone. It's just no longer all that useful. Okay? There is processes in which we can recover some of the energy from there, but not all of it. You'll never be able to reduce this temperature back of this object to its original state without costing more energy to do it. Okay? So you're not going to get all of this energy into this object. Cool? Now, the simple solution to that is, well, conduction. There's no fluid in between there, right? So I'm going to take away this space and I'm going to apply another one there. So here's my one object, here's my second object. This is hot, this is cold, okay? I'm using a wet rag because it is it's sidewalk chalk. Hot, cold. So the hot object has all this motion moving around in there. We've got kinetic energy because hot means that it has a lot of thermal energy, which is expressed in kinetic energy of an object. Okay? So a lot of kinetic energy is going around. And it's colliding with this object and it's delivering energy into this object. Okay? So we're getting energy being delivered there. But what's stopping it from delivering energy to the fluid, the air, or whatever it is up here? What's stopping that? Nothing. Well, okay, well then I'm just going to pump all the air out of there. I'm going to remove all the fluids in here so there's only two objects. So I can improve, so that way all that energy doesn't go out here striking all those air particles and delivering energy into that. It's all going to have to go into this cold object. Perfect. That way I can conserve all that energy. Nope. Doesn't happen that way. What ends up happening is that these objects have motion. They have that kinetic energy. And it wants to get rid of that energy. So it will deliver a good chunk of it to this cold object, but it will also give off radiation in the form of light. I mean, how many times have you seen a hot object, I shouldn't be touching that, a hot object glow? Well, that glowing is giving off radiation. That glowing is light. And light is nothing more than radiation. Okay? So I don't get all the energy that's stored in here to there. And as a matter of fact, as I'm delivering energy to this cold object is heating up and starting to glow itself, giving off this light energy. Okay? So you're not going to be able to maintain this perfect system. The energy of that system is slowly decreasing and decreasing and decreasing. Okay? Because of all of these other processes, because of those three methods, because of the second law, that convection, conduction, and radiation. It has all these methods in which to get rid of energy. It may be delivering a good portion of energy to this cold object, but there's still these other pathways in which it can take, therefore lowering its temperature and trying to achieve thermal equilibrium. So the second law is stating that the amount of useful energy that's in a system is slowly decreasing. Okay? Which takes us to the next topic, which is efficiency. Cool? So, next video.